And it's being recorded. All right. So what we'll do today is we are going to go over two sample questions for exam two. So your exam two is going to be focusing on the use of arrays and also control structures. So we are going to use conditional statements, do while loops, and also while loops in conjunction with arrays. For the most part, your exam two will be basically traces of algorithms that I provide, and the correct answer will have to follow the format that we have been using in this class. And obviously, the correctness is also an important part of the traces. Yes, it will be the next Wednesday. Yep. So 1 week from today. So that's a typical thing that I do. I will give you like a practice session, and then 1 week after the practice session is the actual date of the exam. So the exam is going to be open book, open notes, but everything has to be on paper. If you feel more comfortable with a calculator, you can bring one with you, even if it is a graphing calculator. I don't think you will need a graphing calculator for this exam. Anything that can perform basic arithmetics should be fine. But if you feel more comfortable with a TI 80 something calculator, you are also allowed to bring a calculator like that. So we'll start with some practice questions. Okay, so the practice questions are already in the announcement. So hopefully someone has the time to look at the first practice question. I make up another practice question just earlier this morning because I think one may not be enough. So we'll start with the first one. So this is the algorithm, and I need so the answer is going to be a trace of the algorithm. So I'm gonna copy and paste the usual thing. Okay, make a screenshot of this so that I can keep track of the algorithm in the trace. And then the trace is, I opened one, yeah, this one. So this spreadsheet is already shared with you in the shared folder. So if you want to follow along, you can do that. That's the question. In the shared folder. Yeah, in the shared folder, and it has today's date as, huh? You know what? It is already in the shared folder. It is created in the shared folder. So if you go to the shared folder, you should be able to find a Google Sheets of today's date on it. So if you want to follow along, this is, you can do so. If you want to focus on the projector, that's fine too. Okay, so um, taking notes can be a little bit tricky. Okay, so you may not want to take notes, just kind of busy copying everything. You might want to just write down what you understand about the process or things that you think is important that I did not say. So those are the things that you might want to write down in your own notes. All right. So we're going to start with the tracing of this algorithm. To trace any algorithm, the first thing you need to know is how many columns do we need. So with this one, because we are not using functions yet, so the comments column can still be all the way to the right-hand side. But since we have been changing the comments column to be column A or the first column, so I'm just going to follow that rule. So we have one column for comments, one column for line number. So those two are mandatory. So now we have to look at this algorithm and find out what else do we need for um, columns. I typically would use one column for n, even though n is not going to change. It is still going to be useful to keep track of n. We have a variable j here. Okay, so j is going to take up a column. And then we also have array A. Now, array A has many elements. The question itself states, n equals to 5, so the array has 5 elements. So now we basically have to create 5 columns for the array. So A bracket 0, A bracket 1, A bracket 2, A bracket 3, and A bracket 4. So I believe those are the columns that we need. And there's also a variable called t, so that also needs its own column. So before I do that, I might want to change the width of the existing columns because they don't need to be this wide. Yes. Uh, It's part of the question. So when you look at the question itself, it says n equals 5. So that tells you that the array has 5 elements. All right. So we are ready to get started with the trace. Yes, go ahead. Question? Oh, okay, let's do it. So we know the value of n is 5, but everything else has an unknown value. So the precondition can only say something about n because n is given to you, but everything else are basically just a question mark. So in the exam, you do not have the option of using a spreadsheet program like what I'm doing now. So you need to do this on paper, which means bringing along a ruler can be very helpful. I can give you lines, in the question itself, or you can use your own paper. Which one do you prefer? Either way. Okay, so I think it's safer for you to bring your own pieces of paper because if you do that, you can actually pre-print your name and student ID on that paper just in case, that answer, kind of is detached from the exam. I will still be able to say, oh, okay, this is, this belongs to this person and this is for question number 2. So you can prepare all of that ahead of time, which can be helpful, which does not mean that I won't bring extra paper. Okay, so I will bring extra paper in case anyone needs the extra paper. But I think it is better for you to bring your own paper already kind of lined and bring a ruler so that you can basically draw the vertical lines to separate the columns, which makes it a lot easier to read. And anything that is not legible to me, I cannot grade. Okay, as much as I want to be able to know, okay, I'm not really sure what this is or how the rows line up. If I cannot see how they line up, I cannot mark it as a correct answer. All right, so we are now ready to go. Line 1 is just initializing j to 0, so j gets a value of 0. And then line 2 is a while condition. Any type of while if statement, we need to evaluate the condition. So in this case, the condition is we look at j times 2 and then we ask whether that product is less than n. J is a 0. 0 times 2 is still a 0. 0 is less than 5 is true. Okay, fine. We'll say it is true. And then where do we go? The condition of a while is true. So where do we go? The following line. Okay, so that is correct. So we go to line 3 in this case. So line 3 is the if statement. So now we have to answer that question again. So not again, this is the first time we deal with this question. So it is asking a bracket j and comparing that to a bracket n minus 1 minus j. Okay, so now we have two expressions to evaluate. The first one is easy, j. J has a value of 0, so a bracket j refers to a bracket 0, which has an unknown value. Oh, okay. So with this one, I actually have to give you initial values. I did not read my own question carefully. Yeah. Yes. Yeah. So I'm going to use mine. Okay. Yes. So mine is 06887. There we go. Okay. Because otherwise, I look at the comparisons, it's like, what are we comparing? So I do apologize. I did not read my own question carefully, but I spotted it. All right, so we're comparing a bracket j, which is a 0. Is it greater than a bracket n minus 1 minus j? N is 5, 5 minus 1 is 4, j is 0, 4 minus 0 is just 4. So we, when we refer to a bracket n minus 1 minus j, we're referring to a bracket 4. That is correct, which has a value of 7. 0 is less than 7 is false. It is not true. Okay, so if the condition of a conditional statement is false, where do we go? Line 8 is correct. We don't have an else. Correct. Yes. So if it had an else, then we would be going to the else. but since this one does not have an else, which is equivalent of having an else that is empty, so that means we are done with the conditional statement. So we continue execution on line 8. So line 8 is right here, and then we just go like, okay, so what does line 8 do? We add 1 to j. J gets j plus 1, so j is incremented to a 1, and then where do we go after line 8? Go back to line 2. That is correct. Because this is a loop, okay? We have to go back and reevaluate the condition. So j times 2 is less than n is still true because j is now 1. 1 times 2 is 2. N is still 5. 5. 2 is less than 5 is true. So now we continue the execution of this code. And then we go to line 3. So line 3 is, it looks exactly the same as last time, but because J has changed, so the two elements of array A that we're comparing also have changed. So this time we're comparing A bracket 1, because J has a value of 1, against n minus 1 minus 1, which is 3. So we're comparing A bracket 1 to A bracket 3. Is 6 less than 8? Greater than 8? The answer is nope, it is not. So it is false again. So my student ID does not help with illustrating what to do within the conditional statement. So I might need to change that and retrace the algorithm. So now we move on to line 8 again. And line 8 is going to increment j by 1, which is now 2. And then we go back to line 2, which reevaluates. J is 2. J times 2 is a 4. 4 is less than 5 is still true. So now we move on to line 3 again. So this time it is interesting because A bracket J refers to A bracket 2. And then A bracket n minus 1, which is 4, minus J, which is a 2, is also referring to A bracket 2. So we are comparing A bracket 2 against A bracket 2. The value of one element cannot be greater than itself, so this is automatically a false, which also means we skip to line 8, which increments j from 2 to 3. And then we go back to line 2 again. Okay, re-evaluate this condition. J is now 3. 3 times 2 is a 6. 6 is less than 5 is false. So now we are all done with this loop. So we get to post right away. And that concludes this particular trace. So do we have any questions about this particular trace? No questions? All right. So uh, my ID just did not work. Okay, it did not demonstrate the case of, what do we do when we get into the conditional statement? So let me go ahead and change the ID so it's not actually my ID. In fact, I would reverse the whole thing. So I would spell my ID backwards, so it becomes 78860. 78860, because this will cause it to trigger the then statement twice. Okay, so we're going to retrace this algorithm. I'm going to erase all of this. And the current time is 9:13:38. So if you guys want to go back to the first trace, you can go watch the video and just rewind the time back to 9:13. That will get you back to the trace of the first example. So now we track the second example, which is about the same. Okay, it's really close. J has a value of 0 to begin with. We go to line 2, oops, line 2, and then we evaluate whether J times 2 is less than n. It is true. We get to line 3. A bracket J is A bracket 1, A bracket 0, which has a value of 7. Is it greater than A bracket n minus 1, which is 4 minus J, that makes it 4. So now we look at that, and that's a 0. 7 is greater than 0 is true. So that means we go into the conditional statement. The first thing we do is on line 4, we copy the value of A bracket 0 to T. So T now has a value of 7. We get to line 5. Line 5 evaluates the right-hand side first, which is A bracket 4, which has a value of 0. And then it uses that 0 to update A bracket 0. So A bracket 0, which is column E, is now updated to a value of 0. This 0 is coming from this 0 over here. And then we get to line 6, which just copies the value of t, which is 7, to a bracket n minus 1 minus j, which is 4. So a bracket 4 is now updated to a value of 7. In essence, we just exchanged the values of a bracket 0 and a bracket 4. Do we have any questions about these three statements as the then portion of the conditional statement? Nope. Okay. Huh? On line 4? On line 4, the, the, the algorithm specifies t equals to a bracket j. So which part do you have a question about? How we got 7? No. Okay, so let's look at line 4 specifically. Uh, what kind of statement is line 4? We only have what, four kinds of statements or five kinds of statements. We have conditional statements that starts with the if. We have a pre-checking loop that starts with a while. We have do statements that starts with the word do. And then we have block statements which starts with an open brace. And this one does not fall into any one of those. So what is the fifth kind of statement in this class? Starts with an A. It's an assignment statement. Okay, very good. An assignment statement has two sides. Okay, it has a left-hand side and a right-hand side. Which side do I evaluate first? What does an assignment statement do? We evaluate the right-hand side, which comes to a certain value, and then we use that value to change the variable or things that can change on the left-hand side. Very good. So now we look at the right-hand side, which says, a bracket j. What does that mean? When did we talk about? Yes, go ahead. How do we know j is 0? Because we keep track of it. So by the time we get to line 4, j still has had a value of 0. So a bracket j is the same as a bracket 0, and which has a value of what at that time? Yep. So you have to mechanically do everything, right? So the exam or the test is really just assessing whether you remember all the mechanisms. When you encounter a certain construct, do you know what to do? And all of those were discussed in the lecture and also in the notes. Okay. And okay, so this is probably a good time to remind everybody in this class that the exam is still open book and open notes. So that means you can literally print every single module that I have written, in Canvas and bring it with you. You can bring all your notes. If you guys want to study together and come up with your, how do you call that? Study guide. Okay. If you want to come up with your own study guide and your own material together, that's fine. If you want to make copies and share with your friends, that's fine. You just cannot exchange the paper during the exam. Okay. So make sure that you remember to bring the pieces of paper that you think will be helpful in the exam. Because if anyone forgets to bring that, the pile of paper, I cannot help. Okay, that person will have to finish the exam without the uh, additional help from the paper. Okay, so it is. So you have to remember. So did I answer the question about line 4? Okay, excellent. And the more important question is, do you know how to study for this class for the exam? because because during the exam I cannot answer questions like that. Okay, I cannot answer questions like what does this symbol mean, or how do we evaluate this expression. I cannot answer the questions like that because that would defeat the whole purpose of the exam. Okay, now what kind of answer can I address? It's like, oh, um, what is yeah to clarify what the question is asking. I can clarify those things, but I cannot answer questions about how what to do with a conditional statement or what to do with a while loop. Okay, because that's exactly what the exam is supposed to be assessing. All right, so now we can move on. Okay, so we are done with line 6, and after line 6, where do we go? Nope, it is not line 2. It is line 8. Okay, so you might need to think about why it is going to line 8 instead of line 2. Okay, the reason why it goes to line 8 is because the conditional statement starting on line 3 and ending on line 8 is line 7, sorry, is sequential. It is the first of two statements in the block statement, which starts with the open brace on line 2, which ends on line 9. Okay, so we move on to line 8 in this case. We just add 1 to j. J goes from 0 to 1. We go back to line 2 in this case. J times 2 is less than n is still true. And then we go to line 3 again. So we compare a bracket j against a bracket n minus 1 minus j. But this time j is 1 already. So that means we're comparing a bracket 1 against a bracket. What is n minus 1 minus j? N is 5, j is 1. So what is this expression? What is the value of this expression here? And that would be 3. That is correct. So now we are actually comparing and see whether this 8 is greater than this 6 over here. The answer is true again. Okay. So now we have to go into the conditional statement on line 4, starting on line 4. On line 4, we use T to remember what is A bracket J, which is A bracket 1. It has a value of 8. On line 5, we first evaluate the right-hand side, which is A bracket n minus 1 minus j, which is A bracket 3, which is a 6. And then we use that to update A bracket j, which is A bracket 1. So that's why column F is updated to a value of 6. And then we get to line 6, which is using the value of t, which is 8, to update A bracket n minus 1 minus j, which is A bracket 3, which is on column H. So column H is now updated to a value of 8. Then we move on to line 8. We add 1 to j. J goes from 0 to, excuse me, from 1 to 2. And then we go back to line 2 to reevaluate. J times 2 is less than n. It is still true. And then we go to line 3, which is now comparing A bracket 2 against, guess what, A bracket 2 again. And that is also automatically false because the same element cannot be greater than itself. So that saves us a lot of trouble. And we just go straight to line 8. We add 1 to j. J goes from 2 to 3. And then we go back to line 2. J times 2 is less than n is now false. And then we get to post. All right, same algorithm, traced slightly differently with different initial values in the array. But for the most part, the logic is the same. Do we have any questions about this second trace of the same algorithm, but using a different ID? Okay, very good. All right. Does anyone need more time to think about whether they have a question and also how to ask that question? Because I know sometimes it takes a little bit more time to process. Okay, all right. So without any further question, I am moving on to the second question that is in the announcement. All right, this is the first question. The second question is in some way easier than the first one. So this is the second question. The second question is once again an algorithm that has that uses arrays, and we'll go ahead and track this one. So once again, I'm going to let me get rid of this first because we don't need that anymore. And then I'll just copy or just kind of clip the portion that I need, which is only this portion. And this time it will take up a little bit more space because we have two arrays and each one has 5 elements. So it's going to take up a little bit more space this time. All right, so we just add a new sheet here. Same thing, we got comments, line number, we have n being 5, okay, so this one we know already. This is the precondition. And then we have two arrays this time. So we have A, which has A, okay, I'll just be on the lazy side now because I can copy and paste from here. So these are the 5 elements from A. Go to sheet 2, paste like that, and I'm gonna have to shrink the columns in order to fit all the other variables here. So now we have also B, so B bracket 0, B bracket 1, B bracket 2, B bracket 3, and B bracket 4. Okay. All right. As a part of the question, we also have assumptions about the values in array A, and they have these specific values to begin with. So as a part of the precondition, we also specify A bracket 0 is 5, and then a 1, and then a 6, and then a 2, and then a 7, and then B is all unknown because all the elements of B are unknown because we did not say anything about the initial value of the elements of B. And then we need one more column for I. So I'm going to put I right here. Okay, insert one column to the left and then put I right here. It is also unknown to begin with. So anything, any variable that did not explicitly has an assumed value would be unknown to begin with. All right. So now we start execution from line 1, and this time I did not write down the line number, but I think we can count because all together they're only like 5 lines. So I think we can count. So this is line 1. Line 1 says I is initialized to 1, not 0. Okay, so it is starting with a value of 1. And then we get to line 2, and line 2 is initializing B bracket 0 to be the same as A bracket 0. A bracket 0 has a value of 5, so column J, which is B bracket 0, would also update to a value of 5. And then we get to the while statement. I has a value of 1, which is less than 5. Okay, that is true. So I is less than n is true. Then we get to line 4. So line 4 is quote unquote the only complicated thing happening in this algorithm, but it doesn't really change anything. We just have to, we always evaluate the right-hand side of an assignment first and then use the value to update the left-hand side. So the right-hand side is just a little bit more complicated than usual because it refers to B bracket I minus 1 plus A bracket I. So we just have to evaluate one at a time. I currently has a value of 1. I minus 1 is going to be 0. B bracket 0 already has a value of 5. And then we also have to add to it A bracket I. I is 1. A bracket 1 is a 3. So we are adding 3 and 5 together to be an 8. So 8 is going to be used to update B bracket I, which is B bracket 1, because I equals to 1. Do we have any questions about line 4? Because of this entire algorithm, line 4 is really the only one thing that is a little bit on the challenging side. So are we good so far? Okay. And then we get to line 5. Line 5 doesn't do much except to increment the value of I by 1. So I goes from 1 to 2. Then we go back to line uh, 3 again, which is the beginning of the while loop. I is 2. 2 is less than 5 is true. So we go back to line 4. So this time we are adding B bracket I minus 1, which is B bracket 1, which is this 8 here. And we are adding to that A bracket I, which is A bracket 2, which is a 6. So adding those two together is a 14. So 14 is going to go here. And then we go to line 5, which adds 1 to I. I goes from 2 to 3. Then we go back to line 3. I is less than n is true. And then we go to line 4. So line 4 this time is going to add this 14, which is B bracket 2, to A bracket 3, which is 2. which now add up to a value of 16, which is then stored to b bracket I, which is b bracket 3. So 16 is going to be stored here. And then we get to line 5. I is now incremented to 4. Then we go back to line 3. I is less than n is true. Then we go to line 4 again. And then what we do is we pick up this 16, and then we add the 7 here to the 16, which is what, 23? So the 23 is going to be stored here. And then we go to line 5 again. We add 1 to I becomes 5. And then we get back to line 3. So when we get back to line 3, I is already 5, n is always 5, 5 is less than 5 is false. And that concludes the whole thing. So we get to post right at that point. All right, so do we have any questions about this particular trace? Hmm? Yeah, well, I mean, it's not, it's about understanding the mechanism. Yeah, it's about understanding the mechanism. Um, yeah, how to access the value of an element in an array. And the key is to evaluate the expression inside the brackets first. And whatever that value turns out to be is going to help you identify which element in the array do we really want to access. And that's about it. Okay, that's the only trick related to arrays is how do we access a specific element in an array. All right, so that's that. Okay, so that is all that I have as sample questions for the exam next Wednesday. Um, do we have any questions related to the scope or other aspects of the exam next Wednesday? Yes, it will just be arrays. It will be arrays and all the other things that we have talked about. So you still have to obviously remember how to do conditional statements and whatnot. And functions is not on the next, is not on exam two. So all the return line number stuff, that is not on exam two. It'll be 3 to 4 questions, and each one has a trace about this long, with this kind of complexity. So it's not my intention to make it super tedious so that you guys just have to do a lot of tedious work. My the purpose of the test is to see whether you guys know how to um, trace the algorithm, so I know whether you understand the mechanisms themselves. Okay. Any questions? Okay. If there are no questions, we'll move on. Yes. So we are moving on back to um, not local variables. Let me kind of get rid of the ones that I don't need anymore. Return values we have talked about also already. This is binary search. And this one is returning value again. And then this one is returning a value. So we are done with those. All right. So parameter is where we are at. Okay. So now, okay, I just added just a little bit to the module that was presented to you on Monday. So the only change that I have, or the only thing I have added, is a general rule related to parameters. Okay. So we'll just go ahead and read this portion here. In an invocation to a function that has parameters, the caller, basically the invocation itself, has to specify the values of the parameters. Each value is called an argument, or each value of a parameter is called an argument. In the trace that we do in this class, the parameters, each parameter is allocated a column, but it has to be allocated prior to the return or the return line number column. In the execution of the called function, parameters are accessed like local variables. Okay, so that means, for the most part, parameters are like local variables with only two main differences. The first one is when are they allocated, in the trace, and the second one is do they start with initial values? Do they start with some kind of known value? Parameters do, variables do not. Okay, and parameters are deallocated when a function returns. So that means when we deallocate the return column or the return line column, we also deallocate the columns associated with the parameters. Is that okay? So that is consistent with the trace that we did on Monday. It's just a little bit more spelled out like this. Like in general, what do we do with parameters? Hmm? It is to pass information to the called function. That is correct. Yep. All right. Yep. Yep. So in the case of the algorithm that we talked about the other day, all it wants to do is to compute the sum of the two parameters and then return the sum back to the caller. Okay. All right. So now we can do a few things that are kind of interesting. So we'll start with something like this, except there's a little twist to it. I believe on Monday I gave you guys an exercise that is based on this, so we'll start with that. Okay. I believe that is also did I put it into the announcement or was it just in the text editor? I cannot remember. Um, yeah, I think I just kind of put it into the text editor. I did not save it. It's okay. I got it. So what I'm gonna do is really just to take this and then just change it a little bit based on what we talked about the other day. And I can use my own editor here to do the text editing. All right. So I think it is something like, did I just change one of these to another call to add? I think that's what I did, right? Okay, so we'll do that. Okay. Or did I use another plus, with another call to add? Okay, it's like this. Okay, we'll do it like this. Okay. So now we look at this program. Line 6 is still line 6. I don't have to change a single line number in this case, but the trace gets a little bit more interesting. Okay, so now I do the usual thing. Okay, so we copy and paste, or I just make a snapshot of this. So now we know, what algorithm we are tracing, and then go back to the same document, okay, and open up a new sheet in the new document. There we go. All right. So now we want to trace the algorithm that needs to be displayed all the time. There we go. All right. So we set up the columns, okay? Comments is always going to be here. Line number is always going to be here, but it has no variable to talk about in the precondition because x is a variable, but it is called a local variable. And one thing about local variable is they do not exist until the function is being called. So that means when we get to line 4, that is when x is allocated a column. And when x is allocated a column, it always starts with an unknown value. Okay, so that's how we do this. And I can use a boldface here just to emphasize that this is the header of column C at this point. So we can shrink this a little bit and shrink that a little bit. Okay, so that's what line 4 does. Okay, or line 4 to 5. Okay, it doesn't matter which how you count it. Okay, so line 4 to 5 is going to do this. So now we get to line 6. Okay, so line 6 now becomes kind of like a mystery. It's like, how do we do something like this on line 6? We have a call to add. The outer call to add has 23 and the result of add 23 as is arguments. So now the question is, what do we do first? Okay, so think about the order of things. Okay, what is the one thing that we need to do first on line 6? Can we do the outer add, like adding 23 at this point? No, because we do not know what is the value of the second argument. Yes. That is the first one we need to deal with. That is correct. Okay. So what uh, what he meant is, we basically look at this entire thing and say we cannot do the assignment. There's no way we can do the assignment because we don't know the value of the right hand side. We cannot even do this call to add because we don't know what is the second argument to this particular add call. But we can do this call, right? Because this one is fully resolved. We know 2 and 3 are the arguments to the call to this particular add. So that is the add that we can handle first. So that means, we have to now specify x, y as the arguments or the parameters. So x, y are the parameters of add. This x refers to this x here. This y refers to this y over here. So they need to be allocated, okay? And we also need to have a column that is simply called return so that we can remember what else do we need to do when we get back to line 6. All right, so we'll start with x and y. And because we're handling this particular call to add, we know the first argument is 2, which is now passed to parameter x. We know the second argument is 3, which is then passed to parameter y. In other words, the association of argument in the call is to the parameters in the function definition is by position. The first argument goes to the first parameter, the second argument goes to the second parameter, and so on. So everything is positional in C and C++, which is not true for many other programming languages, but in C and C++, for the most part, they are positional. So now we now specify the return column or return cell, which is basically documenting when we go back to line 6, what else do we need to do? Well, we still need the assignment to x. We still have the outer add that we have to perform. The 23 is given to us, but the call that we are handling right now is now replaced with a question mark. So instead of just trying to mechanically remember what to do, I think it is better to remember also what the question mark is for. Why do we use a question mark in this case? The question mark is a placeholder of the return value of the call to add that we're handling right now. In other words, the question mark is what allows the called function to know exactly where the return value needs to go. So understanding the rationale is more important because then you don't really have to spend a lot of energy to memorize the steps because it quote unquote makes sense. Okay. So that is the way that I study, for things, for stuff like this, I need to understand why are we doing this? And then once I understand the why, the how comes usually pretty naturally. Okay. I cannot focus on the how without understanding the why or the what. Okay. But that's just me. Okay, different people study differently, so I can only talk about the way that I study, the way I understand things. All right, so we're going to make these 2 columns a little bit smaller. We don't really need to, but I just like to keep everything kind of packed. All right, so now where do we go? I have set up all the columns already, which means we are ready to continue execution in the called function. In this case, the called function is add, starting on line 1. Line 1 doesn't really have much to do, but I just want to document that we are starting on the first line of the called function. Now we get to line 2. Line 2 is a return statement. There are 3 things that we have to do with a return statement. Okay, we evaluate the expression, after the return, which is x plus y. Okay, we have 2 columns, marked or labeled, or yeah, labeled as x. Which one is x referring to? Let me point out. I'm talking about this x here. It is a reference to a column that is x. So are we referring to column C or column D? Because they are both labeled x. What is the rule? The rule says we always use the rightmost column with that name. So the rightmost column is column D in this case, which has a value of 2. Y is not so much of a problem because there's only one column that is labeled Y, which is column E, which has a value of 3. 2 plus 3 is 5. So now we know the return value is 5. Once we know the return value, The next thing we do is we simply copy and paste the original return cell over here, and then we change the question mark to the return value, which in this case is 5. Is that step understood? Okay, so, and then what we do is we copy this entire cell all the way over here, skip one particular row, and later on we'll, okay, that's the kind of like the second step. And why do you think I skipped an entire row? What is the purpose of the row that I skipped? Or I should say row 9 in this case. This is why I prefer to use a spreadsheet, because I can refer to rows and columns and individual cells because each one has an address. But when I use tables inside the module, there's not an easy way to refer to a specific thing in the table. But in the spreadsheet, it's easy. So why do you think, what is the purpose of row 9? What is it supposed to document? What is the last thing that you need to do when you execute a return statement? Yes, to cross it out, to deallocate the columns associated with the entire call. So in this case, based on the discussion earlier, when you have parameters, they also need to be deallocated when we deallocate the return column. So that means these three columns are going to be deallocated as the third or last step of executing a return statement. So that in this class, I use, I think, a strikeout, which is Alt Shift 5 on the keyboard in Google Sheets to indicate that columns D, E, F are no longer in use at this point. Okay. And then when we go back to line 6, based on the line number column, this is what line 6 has to do at this point. Is that okay? The embedded or the nested call to add with 2, 3 as the arguments is now fully resolved to a value of 5. So that means the outer call using 23 and now 5 can also be called at this point. In other words, now we have the second call to add. So the second call to add will do about the same thing as the first call, which is to reallocate columns for XY and also for remembering the return information. But this time X is referring to the first argument, which is now 23, and Y is now referring to the second argument, which is now 5. And then the return is going to be line 6, and then the entire right-hand side of the assignment is the function that we are calling right now. So that entire thing is now replaced by a question mark as a placeholder so that the return statement knows where the return value needs to go. So I want to make column D a little bit wider because 23 takes up more space. So this is what it looks like in the second call. We are reusing columns D, E, F because on row 9, they were marked as deallocated. And as a result, on row 10, we can reallocate the same three columns. Is that okay? Does everybody understand the process of calling a function that has parameters? Okay, all right. So now we basically do about the same thing as last time. We continue execution at the called function, starting with the useless line 1. We get to line 2. We evaluate, what is the sum of 23 and 5. That would be 28, right? So the 28 is the return value. So now we can execute the return statement, which is copying the return cell, copy, paste, change the question mark to the value actually being returned, which is now 28. And then we copy this to the cell for line number, but skipped one row. And then we just say, okay, now these three columns are no longer needed. So we just strike out these three columns, Alt Shift 5 on the keyboard, and now we can continue execution on line 6 again. Do we have any questions about these steps? Okay, yeah, no questions. All right. So now when we get back to line 6, it looks like this now because we have fully resolved the entire right-hand side of the assignment, which means now we can actually carry out the assignment operation. So now we say, oh, okay, the right hand side is 28. We need to store 26, 28 into X. Column D is now gone. So the only column that is labeled X is column C. So column C is the one that is now updated to a value of 28. And then we get to the return statement on line 7. And because main is a little bit special, so by the time we get to line 7, that means that we are done with the execution of the entire program. So we get to post right away. And that concludes the execution of this particular algorithm. So do we have any questions about this one? Do you need more time to formulate your question? Okay, all right. So in that case, we are now ready to talk about recursion. Okay, so most people or most people teaching this class would not introduce recursion because recursion is perceived to be a very difficult concept to understand. So coming up with a recursive algorithm is indeed difficult. But given a recursive algorithm, to follow it, to trace it, is not supposed to be difficult. So that's why in this class, I introduced recursion early on because I'm not asking you to write your own recursive algorithm. I'm simply giving you a recursive algorithm and ask you to trace it. So those two are entirely different things. Okay. In other words, um, if you think about writing an algorithm as designing a car, and you think about tracing an algorithm based on a known algorithm as driving a car, do you think driving a car is considerably easier than designing and manufacturing a car? Yep, it's kind of like that. Okay, so we are just driving a car right now, and granted, this is not a Tesla, this is not a Prius. This is not like a 1988, Jeep with a manual transmission. So yeah, there are a few steps to the whole thing. You have to change gear, you have to know when to change gear, and so on. But it is still a far less complicated process as opposed to designing a Jeep to begin with. So are we ready to do that? All right, cool. So what we'll do is we're going to use a very classic, but typically not very useful algorithm. It is called, oh, okay, I just messed up this line here. All right, so we'll start a new file. It is called factorial, okay? So it looks like this. F stands for factorial in this case. So we are looking at the factorial of n, and the way this works, okay, I'll give you the most simple and yet easy to understand version of this. So we'll say if n is less than 1 or less than or equal to 1, then we go ahead and return, okay, I'm going to use nice braces over here. So if n is less than or equal to 1, we just return a value of 1. It's a constant. It is the alternative that makes it a little bit complicated to deal with. It is returning n times f of n minus 1. Okay. And then in main, we'll do the kind of usual thing. Okay, this is int main. Main has a local variable x so that we can store the return value somewhere. So x equals to f of, I think 3 is probably a good one. There we go. And then return 0. Okay. You can see the length of this program is not really nasty, okay? I could have written this in a much simpler way, but this is more spelled out and easier to understand. The complexity of, or the perceived complexity of this particular algorithm is what do we do when we are executing line 5? All the other lines are pretty easy. Line 5 is the only one that goes like, ugh, we are in function f and we're calling function f. Is that even allowed? So that would be the focus of this entire discussion, is focusing on what do we do on line 5. All the other lines are kind of like, okay, things that we have talked about already, not too complicated. We should be good. Okay. So are we ready to tackle this one? All right. Let's work with this one. And I'm just going to use the line number of the editor. Okay, not quite enough. Let's do it again. Capture the entire line number. There we go. Okay. So now we can get rid of this. And then we do this. There we go. And then we go back to the spreadsheet and open a new sheet again. Okay, so on this particular trace. This time I might need to shrink the columns a little bit because it gets a little bit longer. It's harder to get a kind of like a visual on the whole thing if I don't do that. But we'll do that when we get to that point. So right now we just do the usual thing. The precondition, there's nothing to say. And then we get to line 9 is the first line, or 8 or 9, doesn't matter which one. So we'll just say line 8. We allocate a column for main, which is a local variable. X is a local variable. It starts with an unknown value. So all of this stuff here is pretty much the things that we have done already. No, nothing too mysterious at this point. And then we get to line 10. Line 10 itself is not complicated. It is a invocation of a function that returns a value, and it also has a single parameter. We have done all that already, right? So this one is like, okay, we know how to do this. So we just allocate one column for parameter n, which belongs to function f, and then we also need a column for return. N as a parameter is getting the value of this argument. So 3 is the argument passed to parameter n. And then the return here is pretty simple too. We just copy and paste essentially the entire line 9, except for the call that we're handling right now. The call itself is replaced by a single question mark, and that's all we do in this case. Are we good so far? In some way, this is easier than the previous example, okay? Because the first call to F is pretty easy. It's fairly straightforward. So are we good so far? Yes? Okay. The complexity is on line 5, okay? So right now we are not quite seeing the complexity yet. Then we continue execution on line 1 of the function being called, which is line 1, which doesn't do a single thing. We get to line 2. It has a condition to evaluate, and is less than or equal to 1. Okay. Which column is n referencing? It would be the rightmost column that is in use but labeled with the name n. Which one would that be? Yes, that is D. Okay, it's a trick question because I made it so much more comp than it seems, right? Okay, because we only have one column that is labeled N at this point, so it's easy to say, oh, we are just referencing column D, which has a value of 3. 3 is less than or equal to 1 is false. Very good. All right. So if the condition of a conditional statement is false and there is an else to that conditional statement, where do we go? We go to the else. So we don't trace line 4, okay? We trace line 5 only. So now we go to the line that we go like, what are we going to do here? Well, nothing has changed because I think some people may be expecting, oh, this is a really special case and we do all of these special things for this special case. No, none of that. The perceived difficulty of recursion has to do with people overthinking. Okay, so mechanically, everything that we have talked about has not changed, which means, oh, okay, so we need to call a function. But tech, we're calling the same function that we're in. No, it does not matter. Okay, we do exactly the same steps as calling any function. So can someone tell me what do we need to do when we call a function? There's only one function call on the entire line. So in some way, this is also simpler than the previous example where we embed a call to add within the call of add. This one has one single call to F. So can someone tell me Are we ready to call this f here? Can we evaluate n minus 1? Well, okay, did we find the value of n on line 2? Yes. So we know what n is, right? If we know what n is, do we know what is n minus 1? Okay. So if n is 3, n minus 1 is 2. So that means the argument on line 5, the call to f, that is now resolved. We are ready to call f, right? So tell me all the steps that we need to call a function that has a parameter. Okay, what do we do? We just talked about this at the beginning of today's class. So what do we do when we have parameters, when the function that we are calling has parameters? What do we do? Each parameter needs to be allocated a column. Okay, so that's what we talked about at the very beginning. Okay, is every parameter needs to be allocated a column and it has to be labeled. Okay, which is what we did here. Okay, on row 5, that's what we did when we called f from line 10. So now we're going to do about the same thing, except this is line 5, right? So we do the same thing. Okay, we need a column for the parameter n. We also need a column for return so that we know what to do when we get back to line 5. Is that okay? Has those steps changed in any way compared to what we have talked about so far? It has not changed. It has not changed. Nothing has changed. Okay? So now we know what n is because it is this n minus 1. Because when we are setting up new columns, this n here is referencing the n that we already know. This n is the one that we're setting up right now. So this n is 3 minus 1, which is a 2. What do we do with the return column? We just copy and paste the entire line 5 and replace the function call with a single question mark. Does that sound familiar? I hope so. Because that's what we have been talking about not only today but also on Monday. Okay, so that should be it should sound familiar. So now we can say, okay, fine, we'll copy the entire line 5, which is return, and then n times, oh, wait, the rest is the function call. Replace that part with a single question mark. Okay, are we doing okay? All right. So nothing really has changed. And then what do? We have now set up the 2 additional columns for the call to f now. Now we go to the called function and start from the beginning. Where is the beginning of the function f? What line should we go to? Line 1. That's right. None of that has changed. Okay? It is perfectly okay to do it like this. Okay? So what do we do now? Same thing. Line 1 doesn't do a single thing. Line 2 evaluates the condition. N is less than or equal to 1 is, okay, which n are we talking about? Which column are we referencing now? We are referencing the rightmost column that is labeled n, which is column f, which has a value of 2. Is 2 less than or equal to 1? Nope. Okay, it is false. So now what do? We continue execution to the else statement, which is on line 5. Line 5 says we have to return the product between n, which is column f in this case, and f of n minus 1. I don't think that we are ready to execute the return statement just yet because we have to evaluate what is the value or what is the return value of f of n minus 1 in this case. N has a value of 2. Okay, we needed to know that in order to evaluate a condition. So n minus 1 is just 1. So that means, oh, okay, we know what argument needs to go here. It is just the value of 1, which means we're ready to perform this function call. Is that okay? So we do exactly the same thing. We allocate columns for a column for each argument in the function call and each one. And then we also allocate another column for remembering what else do we have to do when we return to line 5. Okay, so n now has a value of 1, and then the return information is copying and pasting the entire line 5, okay, which looks like this, and replace the function call itself with a single question mark. Sounds familiar? Okay. So this is, if you think, oh man, this is so boring because we're doing exactly the same thing that we have been doing since Monday, then I go like, congratulations, okay? Getting bored because you know exactly what's going to happen, and this is the same thing that has been happening all over again many, many times already. It's good, okay? Because you're recognizing that we are not doing anything that is different compared to what we have been doing already. The rules and the way we do things has not changed. Okay, we are now calling function f. Okay, we are basically handling this call here. Uh, when we call a function, we set up the columns and then we continue execution at which line? Yes, go ahead. Oh, you're stretching? Okay. All right, so we are calling f again. Where do we start? We go to the first line corresponding to the called function, which is which line again? Line 1. Uh, oh, okay, that's not. I just think zoom out on this side. Uh, it's okay. We can still read it. Yep, we can still read it. Okay, so we have line 1 here, and then we get to line 2, and which n are we referring here? N is less than or equal to 1 is, it is now true because this n is referring to the rightmost column that is labeled n that is not deallocated. So the rightmost column that is labeled n is h, column h, which now has a value of 1. 1 is less than or equal to 1 is true. Okay, so that changes the path of execution because we then go to the then statement, which is on line 3. So now we execute the statement on line 3, which is a return statement. Do we have to call something again on line 3? Nope. Line 3 says just return a value of 1. So we are ready to quote unquote execute the actual return statement. So what do we do when we execute a return statement? We copy and paste the entire return thing, and it has to be the rightmost return column. Copy and paste the entire thing. Replace the question mark with um, the value that we are returning, which is a 1, right? And then we copy and paste this entire cell to, we skip one row and then paste the entire thing to the line number column, like that. And let me do one thing here so that we can see the heading of the column B. Okay, there we go. And then we deallocate the columns associated with this function call. So that would be column H and column I. So both the parameter and the return column, they both need to be deallocated. Alt Shift 5, strike out. Okay. So, all right. So up to this point, have I done anything differently compared to how we usually call and return from a function? Not a single thing has changed. Okay. So the second question that some people might have is, can we really execute a return statement to change a return statement that is in the return column? The answer is yes. Okay, don't overthink about it. Okay, just follow the steps. When you execute a return statement, all you need to do is to figure out the return value and copy and paste the return cell and replace the question mark with a return value. What if it is the same statement? Doesn't matter, okay? But you have to differentiate between the execution of a return statement and filling in the question mark of a return statement that is in the return column. So that is what most people have confusion about is, am I executing the return statement or am I filling in the question mark of a return statement that is in the return column? So that's the only well, that's the probably the most important source of confusion. All right. So with all that done, we are now continuing execution on line 5. And you might be asking, but we got to line 5 several times. Which one are we talking about? It doesn't matter. It does not matter. Okay, we are returning n times 1. So we go through the same process. The first thing is we have to evaluate the multiplication. Which n are we talking about here? Okay, I know this is going to sound boring from me, so I want one of you to say it. The rightmost column that is labeled n. So which one are we talking about? Is column which is column F. Why is it not column H? Because column H is now deallocated. It's struck out already. Okay, so the striking out is important because it tells us those columns are not to be considered anymore. So the rightmost column that has a label of n is column F. It has a value of 2. Okay, cool. So that means we are just multiplying 2 and 1, 2 times 1. Can we do that? Okay, 2 times 1 is 2. Okay, very good. So when we execute this statement, it is basically the same thing as, oh, we are just returning a value of 2 on line 5. Okay, cool. So what do we do when we execute a return statement? We look up the rightmost return column, which is column G. We copy and paste whatever it has to over here, and then we change the question mark to the value that we are returning. Remind me again, what value are we returning? 2. That is correct. Okay. And then what we do is we copy and paste this to the line number thing and skip one row in the process, like so. All right. And then the very last thing we need to do is to strike out the two columns that is associated with this function call. It will be column F and column G in this case. So we just have to indicate that these are now deallocated. And now we continue execution again on line 5. But are we going to be confused about, oh, which line 5 are we talking about? No, line 5 is line 5. A return statement is a return statement. A reference to a parameter or local variable is a reference to a local variable or a parameter. None of the mechanisms has changed. Okay, so now we execute line 5, which is return n times 2 this time. What is this n referring to? Okay, it's referring to the rightmost column that is labeled n that is not deallocated. We have lost track of that because it's referring to column D, which has a value of 3. Okay, so that n is a 3 here. What is 3 times 2? 6. Very good. So we are actually just returning a value of 6 as we execute this particular return statement on row 21 in the spreadsheet. Okay, returning 6. Okay, got it. What do we do when we execute a return statement? We locate the rightmost return column, which is column E, copy and paste what it has, and then we change the question mark to the value that we are returning. And remind me again, what value are we returning this time? 6. Very good. So now what do? Is we copy and paste this cell, skip one row to the column that is labeled line number because that's what we're going to do next. Okay. And then we have to label the two columns, one for the parameter here and one for the return. We have to now indicate those two columns are deallocated because we have concluded the function call or the invocation at this point. So now we continue execution on line 10. But line 10 is, oh, looks pretty simple. The right-hand side of an assignment is 6 as a constant. The left-hand side is x. So we have to refer to the rightmost column that is labeled x, which is column C. So column C is the one that is now updated to a value of 6. We continue execution on line 11, which is a return 0 from main, but that means the program has now concluded, so we get to post. All right. So are we getting this or not? Okay, very good. So if you are getting confused in this process, as I said a little bit earlier, the major source of confusion is, are we executing a return statement or are we updating the question mark of a return statement that is in a return column. So those two are the things that can lead to confusion. But other than that, the mechanisms that we have been talking about calling and returning from function, how we pass parameters, and how we pass a return value, none of those mechanisms has changed in this particular sample program. This kind of programming, okay, whenever you have a function that calls itself or directly or indirectly, is called a recursion or a recursive algorithm. So now the question is, this seems to make things a lot more complicated unnecessarily. So why do we do recursion? Why is recursion important in computer science? It has to do with things that are self-similar. In other words, you break a bigger problem into a smaller problem of the same nature. Have we seen anything like that in this class? Where we have a problem and the subproblem, as one step to break it down into a subproblem, the subproblem looks exactly or almost exactly like the original problem. Have we solved problems like that in this class? And what would that be? Yeah, but there's one particular problem that fits into that description the most. Binary search. Binary search. Okay, so we I know we only have 4 minutes left, but I will illustrate why binary search is can be turned into a recursive algorithm. The one that we looked at was not recursive, but it is a recursive quote unquote problem solving mechanism. So I'll give you an example. So we'll have a 2, 4, 10, 15, and then 21, 22, 1, 2, 3, 4, 5, 6. I need one more. Say 25. Okay. So these are the array elements. I'm not even going to name bracket 0, 1, 2, 3, 4, and all the way up to 7 in this case, uh, up to 6. Sorry. Okay. So the mechanism goes like, oh, if all of these can contain the value that I'm looking for, let's just say that I'm looking for the value of 20. Okay. So 20 is what I'm looking for. So the mechanism says, let's start from the middle, okay? And then we can rule out one half, one of the halves here. So since we're looking for 20, 20 is greater than 15, and because in a sorted array, these things are, one element is always less than or equal to the other one. So that means, oh, okay, cool. We just rule out this entire part, right? That's kind of the principle of binary search is by one single comparison, we can eliminate about one half of the possibilities. Yes? Okay. So that means, oh, what is left with the array is kind of the same problem that we started off with, except we started off with 7 values to begin with. Now we only have 3 values, but we're going to do the same thing. We find the middle of the 3, which is this 22. We do the comparison. 22 is greater than 20, but because everything after that is at least 22, now we go like, oh, okay, we can now rule out this half here. And then we apply the same approach again, except this time we have an array of only one element, which has to be the middle element itself. When the array has one element, the only one element has to be the middle one. So now we compare this, okay, 21 is greater than 20. So that means everything to the right hand side of 21, there's nothing to the right hand side of 21. So that means I have just ruled out every single element in the array to have the value of 20. But do you see the self-similar nature of every step that we perform binary search? We ended up with a problem that looked almost exactly like the original problem, except it is smaller. That is the reason why recursion is useful, okay? Because in recursion, we just have to say, oh, this mechanism will solve a problem like this kind. And then in order to solve the problem, we break the larger problem into smaller problems, sometimes plural and sometimes singular. But then we can use exactly the same function to handle each of those cases. Okay, and there are many benefits to doing things in a recursive way rather than what we call iterative, which means that we're using a do while loop or a while loop. And those things are kind of important, but we'll talk about those later. So right now, not counting exam two, our focus is on recursion, function calls, and there's one more mechanism that we kind of have to talk about when it comes to parameters, and then um, and then we'll see how much time we have left in the semester at that point. All right. So we are done for today's lecture. The recording will be uploaded. If you don't see it, just send me a nudge